Hi everyone, my name is Zach Hoylman and I'm a research assistant professor at the University of Montana. I'm excited to be here today to give you my perspective on this important question: why does non-stationarity matter for drought indices? I'm joined by my colleagues in the Montana Climate Office, Kyle Bocinsky and Kelsey Jensco. And before I begin, I'd like to acknowledge that this work and the concepts I'm going to be presenting today have been developed over many communications with state and federal partners across the United States. So thank you to everyone who has contributed to this work. I'd like to start this conversation by thinking about drought assessment and how it's impacted by climate change rather broadly. Drought is, by definition, an abnormality in dryness, and this means it's a relative, temporary, and cyclic phenomenon. And in drought science, we use reference periods to help us to contextualize how severe drought conditions are. In climate science, it's quite common to use a 30-year reference period to define anomalies, or the use of climate normals, but conventional drought assessment often uses long climate records to define drought. But it's important for us to remember that traditional drought assessment tools, like drought metrics, implicitly assume climate stationarity when using long reference periods. And in some locations, aridification is leading to drier average conditions, which is fundamentally changing our contextual baseline, or those reference conditions. And the changing character of drought requires adjustments to monitoring, relief, and adaptation programs. So, how can we account for non-stationarity in drought assessment? Well, one method would be to leverage the notion of 30-year climate normals in drought assessments. This would help us to align drought assessment with contemporary conditions and keep up with future climate change. And this will also allow us to develop targeted climate adaptation programs where drought is changing. This would represent a shift from our reactionary relief paradigm towards a more adaptation-focused paradigm in these locations. So climate change and reference periods. Why do we care? Well, once again, I think it's really important for us to remember that drought is a relative phenomenon, both in space and time. And without a shifting reference frame, some places may eventually be in perpetual drought or perpetual water surplus. But is this really what we mean by drought? Shifting reference frames in climate science are designed in part to address this exact problem. And shifting reference frames are critical to describe realistic expectations of climate variability and change. So let's take an example from temperature. Here I'm showing you data from NCEI, which is showing you the 30-year climate normal average temperatures with respect to the 20th century average, or a 100-year reference period. So in this figure, what you can see is over time, in general, climate has gotten warmer across the United States. And if we were to compare the last 30 years, this 1991 to 2020 reference period, to the last 100 years, we'd be more likely to say that most years in this most recent 30-year period are warmer than normal. And while that's true from the perspective of the last 100 years, it's not necessarily true from the last 30 years. With respect to that more recent contemporary conditions, we've had cool years and warm years over the last 30 years. So how does this concept apply to commonly used drought metrics across the United States? Here I'm showing you the results from two different drought metrics, the standardized precipitation index on the left and the standardized precipitation evapotranspiration index on the right. And what we did was we compared the drought classifications that would be associated with two differing record lengths. One being the period of record, in this case going back to 1895, and another using a more recent 30-year reference frame. Here we're comparing conditions between 2012 and 2021, when that long reference frame since 1895 suggested that drought conditions were either D2 or higher. And what you can see is that in general, anywhere where there's brown shading on these maps represent locations where the period of record suggests conditions are worse than the more recent 30-year reference frame. Similarly, or alternatively, you can see anywhere that's shaded blue is locations where the period of record climatology suggests conditions are actually wetter than the more recent 30-year contemporary distribution. Importantly, anywhere on this map where you see dark brown or dark blue shows that on average we're seeing a difference in drought classification by an entire drought class. In summary, More discussions need to be had to understand the appropriate reference frames for different systems of interest. Here, we demonstrate this point using a 30-year climatology, but what's clear is that these drought metrics are very sensitive to the reference frames we choose to use to contextualize drought conditions and have a strong impact on our perception of drought across the United States. So now I'd like to share my perspective of what this all means. Under stationary assumptions and when using traditional drought methods, drought severity will be exaggerated in locations that are experiencing aridification and underrepresented in locations that are getting wetter when using really long periods of record. And this concept, importantly, applies to other metrics commonly used in drought assessment. For example, in this talk, I've demonstrated this point using the Standardized Precipitation Index, the Standardized Precipitation Evapotranspiration Index, and temperature. But really, this concept applies to any metric that uses a stationary reference frame to compute anomalies. And by shifting to an updating or a moving reference frame, we will achieve the following goals. First, drought assessment will better reflect current day drought risk to affected communities. In other words, drought assessment will be better aligned with contemporary drought conditions. 2, there will be greater standardization across datasets with differing periods of record. And this is a really important point that I will emphasize in the next slide, but the current methods of using the longest period of record possible are inherently unstandardized. Finally, we will better account for climate change into the future. And this is important because our climate projections suggest that we should expect to see additional changes moving forward. And finally, I think this represents an exciting opportunity to develop targeted climate adaptation programs where drought is changing. And this would represent a shift from this reactionary relief paradigm to a more adaptive paradigm in locations that are experiencing rapid climate change. In light of these concerns, we've adopted this framework into our analyses and drought dashboards here in Montana. To conclude this talk, I'd like to show you a list of data providers and data sets that are commonly used for drought assessment across the United States. What you can see in this table is that the reference periods used for each one of these data providers varies quite significantly. And what this means is that this notion of using the longest period of record possible is an inherently unstandardized approach and is based on the arbitrary record length of the data set itself. This represents a real challenge in drought assessment because each one of these data sets and data providers will provide a different assessment of drought severity simply due to the amount of observations in their period of record. And with that, I would like to say thank you very much, and I hope you enjoyed the rest of the presentations today. And if you're interested in more of the details behind a lot of this work, I invite you to check out this publication shown at the bottom. Thank you very much.